Good morning, everyone. Buongiorno. I will start, of course, with self-proclaiming. It's about me. It's me, and so you know, I'm at Zalando. And now, how many people don't know what Zalando is? Okay. So, how many people know what Zalando is? Okay, this is better. Okay, this is a better question. In the States, it's completely different. For example, nobody knows what Zalando is. Yeah. So I was called here to talk here and open this great conference to talk about Postgres, and I will be talking about the ways how to actually integrate data in Postgres, out of Postgres, and how cool Postgres is for that. And I will start with a small kind of history of Zalando. Zalando is a relatively young company. When I started there, it was approximately 6 years ago, and one of the dinosaurs there. And I haven't died yet. So Zalando, we grew a lot. As I started at Zalando, it was only 40 people in technology. Now it's much more. Now it's 10,000 people in the whole company. And we started in Berlin. We grew. So these are only the technology offices of Zalando. And we have, as I said, 40 people in the beginning, and now it's more than 1,200 people. Many people ask, what these people do? It's a good question. We're working to sell even more shoes. I will start with the history. So we started a prototype with Magento and PHP, and at some moment, in several months after growing like about 100% per month, we became the biggest Magento users in the world. We started patching it. We were using MySQL, and it didn't work. So the CTO back then knew me and called me and said, "Oh, come, we have to switch to Postgres." So we did. And it was a very interesting project. I hope, I wish all of you could be able to participate in such a project. We were not sleeping for 5 weeks. Working for the weekends, and we rewrote everything from scratch in Java, Postgres store procedures, and automated everything with Python. Of course, it was not only these 5 weeks that we used, but a little bit longer. So it stretched to more time, and we used the typical microservices architecture. This is probably what most of you actually need, and this is very stable architecture. So Postgres is a rock-solid database. Java backend is a rock-solid and well-known architecture to use, and very stable. We implemented everything. It's an interesting journey. We actually threw out all the third-party software providers except SAP. It's impossible to throw out SAP if you don't want to do accounting by yourself. But at some moment of growth, we hit the wall with questions like this. Developers started to say, what is, we don't want to do Java. Thank you thank you for all the fish, thank you for teaching us SQL, we go to somewhere else. And we taught them SQL well. We organized the internal trainings. We taught how to use SQL and how Postgres works. If you want to enable developers to use Postgres with full power, you have to teach them. You have to teach everybody how Postgres works. It's very simple and very complex in both sides. So, but our goal is to teach everybody how things work, how systems work, and only this way we can build really cool systems. So, to tackle the problem that we have, this is actually the problem of growth, and I understand that not everybody has these problems, but still, I want to show you what kind of problems we hit organizationally and how we want to solve them. We proclaimed radical agility. It's kind of our new VP of technology was pushing it really with huge effort. And we proclaimed that autonomy, purpose, and mastery is the most important things in the company, in the technology. And we proclaimed that autonomous teams can actually choose their technology stack. You already feel what does it mean. We proclaimed that everything should be built in AWS, not to stop us from growing. Yeah, so we hit the walls of our own data centers, not our own, but kind of data centers. At the moment, we had the situation when buying a single disk was kind of a 4-week journey. So we decided to move to AWS completely, but it has problems. So to make the principles that we proclaimed, autonomy and mastery, really work, it's very difficult to give people AWS accounts, say, do whatever you want, and still, being a publicly traded company, comply to the audit requirements. And if some of you here are from regulated industries, then you very well understand what I'm talking about. It's not an anarchy. So autonomy is not an anarchy. You need a structure there, and you have to support it, and it's a lot of work to support autonomy. And we built a small thing, so I'm just mentioning it. I don't want to go into the details. Stoops is a system that we built to enable audit-compliant deployments of inside AWS. This is simple in this slide. In reality, is this horror. Yes, we have a special team that is kind of evangelizing and showing how to make it usable. So, but if you have fun and time, and if you are from the regulated industry and want to go to AWS, then have a look on the open source repository that we have. Another thing that we said will help us in making autonomous teams strive is that we proclaim that we will use microservices. How many of you are trying to do microservices in your companies, or, oops. Okay, so I have to rewrite my slides very fast. So you don't have these problems, but if you will decide, something like this, maybe. So if you are deciding to go to this really cool and really well-hyped approach in building systems, be aware. Every new hype approach has its advantages and, as you know, disadvantages. So what is the typical kind of, then I will talk a little bit more about microservice as it is. So what is microservice? Microservice is a service that is as small as possible, as reasonably possible. Usually the reasonable, possibly small code is the code that your team can rewrite from scratch in 1 week. And the idea of this is that if your piece of code, isolated piece of code, is rewritable from scratch in 1 week, then actually you are not afraid of changing technology that is kind of this piece of code uses. You can start with Java, you can think, let's rewrite it in Haskell, or let's rewrite it in Clojure, or Lisp, even, if you are crazy enough and brave enough. And the only place where you are standardizing is actually your interfaces to the outside world. So the microservices as pieces of software are talking to each other using some standard technology, and as our VP of technology proclaimed, he wants to buy shoes using curl. So it's a good idea to have an open standard protocol and a simple human readable protocol to operate with your system. So REST APIs, and they are hidden behind the walls of the VPCs, including the databases. So the idea there is also that this separated and isolated piece of software actually is not sharing database with any other microservice. This leads to quite a big fragmentation of your database landscape. Currently, at Zalando, with our microservices, we have 150 databases. Every of these databases is varying from 50 megabytes to 5 terabytes in size. We've built a lot of automation, we've built a lot of cool stuff to deploy Postgres easier than it already is. But with microservices, I want to kind of cover some problem that many people don't think about when they are kind of pushing into that direction. The ETL process, the extract, transform, and load process that was working perfectly in the ETL process is impossible. I will mention what I mean. So how data integration is usually working in the classical world, in the world without microservices, not this hip and cool world that we're trying to build. In Italy, you know these things. So we have developers, we have DBAs, we have business intelligence. So DBAs are controlling the databases. The business intelligence people are writing ETL processes, extracting data from your Postgres database, operational databases, into data warehouses. The data warehouse has completely different, the data warehouse database usually has completely different characteristics. You can actually afford being a little bit slower, maybe you can afford some things that you shouldn't afford on your operational database. And in our world, it was kind of a lot of databases, kind of one big ETL process at extracting data from these databases into the data warehouse. Many teams didn't even know that the business intelligence people are extracting data from their databases. This is how good Postgres is, because in other databases, they would have to know that somebody is accessing their data on the fly, kind of in production. Yes, I want to classical ETL process. I already talked about it. So it's the only problem with that is you have to know your use cases extracting the data. You usually know what exactly you want to measure to extract the data from the database and put it into into your data warehouse for further processing. Advantage of this, you always know what you have in your analytical database. It's not like you don't know what you extracted from the database. You wrote this script that extracts it. But with the microservices, as I said, there are some problems. So we have much more services. They all have their own persistence layers. Developers are very happy. You saw that junior developers are also on this picture, yeah? So it's, we are not so happy, but the business analysts are crazy. So when we were announcing this, move, we were running like crazy and saying, what should we do? What should we do? You know this as a typical caricature about what is our plan for disaster recovery? Yeah, just run in circles and cry, help, help. So practically like this. But we then, at some moment, we wept and we cried, and then we decided, okay, now we have to find the solution to this wonderful problem to still keep our developers happy. So one thing that we said is important is we started to build this kind of the Nakadi event bus. This is a small broker that is sitting on top of Kafka or not Kafka. It's actually not bound to the underlying queuing pub subsystem. And we said we can actually put every changes in entities that our microservice is owning onto the event bus. And from this event bus, we can actually extract data as we wish. And actually, this event bus can be used by other microservices as well to react on some events. If you heard about event sourcing architecture, how many people here heard about event sourcing? Okay, go to your colleagues and tell them about this technique because it's really cool approach. Because actually in event sourcing, and I shouldn't be saying this in this conference, you could actually build your systems without using classical databases. The only database that you use is the unified queue. And then we will talk about extracting it into a cool database. And business intelligence is actually something that extracts data. So business intelligence is another service that extracts everything that is published on Event Bus down into their killers and can process it. So, but it would be easy if it is not so simple. If we tried to, if we say, okay, let's publish all the events into the event bus, yeah, how can we do it? The typical way how every developer that I saw before actually does it, they say, okay, from our business logic, we will push data into the database, we will store data in the database, and we will put data afterwards, we will put data in the Nakadi event bus. And they say, okay, if event bus fails, then they say, oh, it's not a problem. Then we first push into the event bus, and then we push into the database. And if the database fails, okay, so, and then we learn what two-phase commit is and what are the problems with that. So how many of you know what two-phase commit is? Oh, yes, good. Many people know. And if you don't know, please go and read. yes, this is very difficult system to implement. So if you try to do so, you need that both your systems support commits and actually prepared commits, and Postgres support it, but not every, so Kafka doesn't support it, for example. So another approach would be to extract data directly from the database. You commit to the database, then the database actually, when everything is committed, actually publishes data itself into the downstream systems. Until recently, it was not possible with the most advanced open source database in the world, but since several years already, thanks to Second Quadrant, enormous efforts, and we actually have the possibility to extract data using the logical replication. This is something that you definitely have to have a look in. What it is, actually. So there are several products that can be used for that, and Second Quadrant actually is pushing the PG Logical plugin that is really well architectured and can be used for very simply to extract data and decode data from Postgres. There is also some product from bottled water, from Confluent, and from people who wrote Kafka. We wrote Tavon, the parallel snapshotting tool that allows you to actually dump the whole database in parallel into your event bus in the moment when you need a snapshot. So if you are starting your process, if you never had any events in your bus, then you actually have to first extract your database in the form of events into the bus, and then go on reading already using PG Logical. This is the kind of a scheme. This is a very cool approach, and if you haven't seen it and you haven't thought about the advantages of this approach, it's really cool. It also not only would work in the use case that I define more or less, that extracting data for data integration, but you also could extract parts of your database and stream changes to another analytical databases without the complexities of big companies. So we need to build some more infrastructure to extract data nicely and integrate it everything from more databases. But if you have one big operational database, and if you want to extract small parts of it into different systems, maybe even not Postgres, then this approach would definitely help you a lot. How you can play with it, there is also the plugin, so there is also Python plugin support already for decoding the stream, and you can actually I will publish this. I will publish the slides, and you will be able to click on the links, because here you, or search for it. I don't know. So another thing, of course. So Postgres is not the only database that supports this. The another database that is cool, DynamoDB, also enables extraction of change streams, and this is, from my knowledge, the only database, the only key value database that supports it. So Cassandra, in Cassandra, it's practically impossible to do extraction in this form, and they will probably need up to 2 years to come up to come closer to the possibilities that DynamoDB or Postgres has for extracting data change events. And with DynamoDB, yeah, if not Postgres, then probably DynamoDB in these cases. Yes. So, Harald, how much time do we have? 20 minutes or 10 minutes. So we can.
20 minutes is if you take your allocated slot, and 10 minutes if you make up for the delay we had.
So okay, I will then try to finish in 10 minutes, and I will start much faster and.
No.
Actually, I don't have so many slides. What I explained is that kind of extracting data from these events from the event bus and putting into the data warehouse can be a complex thing. So it can be a simple thing in case if you have only one or two databases, or it can be a complex thing that we have. So what we decided to do is we build Saiki data platform. Don't ask me why this name with horrible names. Every team is autonomous, and they actually are allowed to choose the names for their teams and for their products as they wish. So this very team, decided to use Javanese names for their products, and the only way to translate to Javanese for them is to use Google Translate. So I have no idea if we're using some swear words, but the Saiki is supposed to be a queue. Yeah? So what we are building here, we are building the data lake. And actually, Cranach predicted the creation of the data lake in 16th century. And you even see the dirty data, the cleansing of data, and then nice consumption of data by the data analyst at the end. It's incredibly well illustrated process of data integration that we're trying to implement. So Saiki, what we do is, for now, it's a temporary solution. For now, we extract from Nakadi Kafka into own Kafka. It's a kind of buffer Kafka. From there, we can actually push data into the S3. We use Tukang to clean up it, to deduplicate a little bit, to resolve out-of-order data, to extract, to keep kind of minimal metadata catalog for this data, and allow the data warehouse processes to extract data from this service. This also allows us to build additional materialization drivers that actually can extract data from Kafka or from S3 and put it in different databases. For example, we have a pilot project that we, for now, paused that allows us to extract data flowing from Postgres into the queue, catch this data, and actually recreate it in Postgres databases by analyzing the structure of the messages that are flowing in this queue. So if you are interested in something like this, I can show you where the sources are. I can show you the sources. Yes, then we also built the stream processing part of our data integration environment that feeds from the stream and allows us to do the near real-time analysis and reporting. And one of the products that I want to pitch for is the Apache Flink. It's based in Berlin. It has impressively good support, and it's much better than Spark streaming because it was from the beginning built as a streaming system. So it's not a micro batch processing system, it's really a streaming processing system. And we also published the blog post about the comparison between Spark and Flink, and Flink was the way better candidate for our use cases. It has a lot of connectors, and we also use Elasticsearch. I don't know why they chose Elasticsearch. With Autonomy, it's a little bit complicated. You have to constantly work to convince people to use real products, nice products. It allows us for real-time business processing, and actually, if you want to make business decisions fast, you need real-time reporting. You shouldn't overdo it. You have to actually know what you're monitoring and how you react on the real-time events. But having them is a really huge advantage for any business. What else? A lot of space left. No, not much left space. Data lake, another part, but I will not talk a lot about the data lake because it's another topic in itself with all the problems and so on. So what I want to kind of show is that and say that everything we do in that direction is open source. So all the products that I showed here in this presentation are open source and are open to access and open to collaborate. So feel free to have a look, to read the documentation, to open issues, and to try it out. So how much time do we have for the questions? If we have. So if there are any questions, I'm very happy to answer them. If they're not, then you will be able to go out faster from this wonderful keynote. So I hope at least something was interesting in this information. Oh.
I've seen in your architecture you have hundreds of microservices, each one with their own persistence layer, which is even isolated.
Yes.
And then you have later the problem of synchronizing different events coming from different. Surely you've already thought about having 150 separate databases on a single instance so that you get that for free in the same stream of transaction data.
So when I was talking about 150 databases, there are 150 clusters that are separated from each other. Mm. So it's not, they are not located on one.
No, of course. But
of course, this is a big problem, and this tukang, I have no idea what it means. This tukang actually is supposed to do the deduplication. So this is the where is it? Yes. So what we're trying to do, additional thing that we are doing is, and what we're enforcing on the teams, unfortunately we have to, is the format of the messages and some requirements on marking the messages with, marking the primary keys and marking the partitioning keys, so that the ordering is possible. We also, what we also have to do there is to add additional, so kind of flow IDs or transaction IDs to be able to resolve possible locks. So this is a lot of, so this thing is, it only feels simple. At the end, it's kind of mind-crashing but very, very interesting project.
Excellent. So Valentine, I've got a deal for you. I googled up what Saiki is.
Saiki is the queue, and
I know. I googled it up. Where the word is coming from,
this is this guy.
That's one of those. But if you give us a 5-minute roundup of the data lake, please do. Then what? I'll tell you what else is Saiki.
What else? What else is Saiki? I'm now afraid.
You don't have to be afraid. It's funny. Can you dip into the data lake? Because Simon will be speaking about PostgreSQL XL, and the data lake should be something where a boat of PostgreSQL XL could swim.
Yes. So, okay. What we actually trying to do is to we were evaluating Excel, Postgres Excel, and MeetUs data. But for now, we are thinking about putting them into this upper corner, kind of where we materialize data. So the data lake, the classical definition of a data lake that you can find in the internet is usually defined as storage of unstructured data. And I fight against this definition with all my possible vigor. Because this definition is a definition of a data swamp and not a data lake. So, what we are trying to do is to build deswamped, so it's kind of the really structured storage of data. It imposes a little bit more problems on the developers, of course, but it is as any introduction of schema and data structure, it imposes some need to communicate about changes of structure and to have some kind of a distributed way of defining the structure. What we were looking into is to use Accumulo as a kind of storage system for our data lake. Accumulo is the system that is supposedly used by NSA to store all their data, that allows column-based encryption. Data lake or data leak? We decided to go for data lake. And we tried to use Accumulo on S3 without building up HDFS file system around it, not to spend too much time in maintaining HDFS, and we failed. So if you want to use Accumulo, talk to us. We will tell you all the tricks. So now we are going one level deeper and storing data directly to S3 and having a thin layer, I think it's Apache Roger or Apache Ranger, something to be able to define the scopes, security scopes for our data. Because as you can imagine, any system like this in a big company like ours has to be secure, and it will be impossible to, if this lake becomes a leak, yeah, so it will collapse the whole company. So this is very important part. So is it enough of the diving into the lake? Yes. So the waters there are still clean. So it's yeah.
I was curious to know a bit more about the teams at Zalando, how big they are, the autonomous teams, if they are fixed, if they.
So about the organization of the teams. So the teams are from 2 to 10 usually, from 2 people to 10 people. They don't have a lead. So it's kind of organized anarchy, but not anarchy. They have, so it's kind of a group of teams usually have one delivery lead that is supposed to oversee the delivery process and enable the teams to be able to deliver. It is more, we see this role more as a coach that is there also to protect against possible wrongdoings. So it's kind of, if somebody goes and tells me, or somebody, we want to use MongoDB, then we are kind of immediately jumping in and trying to find out what are the reasoning, what is the why and why, and so on. So structurally also we have we implemented this metrics system where every team member also additionally has a people lead that is responsible for personal development of a developer. So for example, this for mastery component of this thing. So for example, if you are interested in going to a conference, or if you are interested in doing some trainings, or you want to switch a team, or you want to, as we all make the world a better place, then the team lead is, so the people lead is the one who is guiding these developers, but they are not involved in development process. So, yeah.
What are the reasons to collect the data from the database using logical change set extraction instead of letting the application send them or write them to a file?
Instead of writing them to...
But I ask, what's the reason to get the changes from the database instead of adding that logic to the application? It can send the changes to another system or write them to a file for them to be later collected.
So this thing I covered here, I think, with the... So you mean like this? To push the changes from the... to push the changes from business logic directly into some kind of a storage. This has the problems that I kind of mentioned. This is a two-phase commit problem, and any file that you will be writing, especially if you are in the cloud, will be gone if your storage is gone. So you cannot build this system highly available. You will be losing data. If it's okay for you to lose data, it's okay. For example, for tracking data, you could dump it into the file and then say, okay, I will taking it from the file and archiving somewhere periodically. But if you are if you cannot afford losing records, then you have to go this way, because either without database at all or with the database. But usually it makes more sense using the database. Have I answered? Yeah.
So, thank you very much, Valentine.